Good afternoon, and thank you for joining us as we continue the series of webinars that Kenny has been hosting. We've been looking at various creative strategies that we deploy to meet today's facade challenges. Before we get going, I just want to explain that through the discussion today, we welcome questions and would ask that you put your questions through the Q&A or the chat window, and we will get to those and seek to bring those into the conversation as the meeting progresses. This afternoon, we're going to turn our attention to Terra Cotta. As you may tell from my accent, I grew up in England and I used to love trips to the Natural History Museum in London. I won't comment on whether it's better than New York, but the facade and its incredible detail always impressed me. And little did I know that I was looking at Terra Cotta, and even less that I would one day be working with a group of people who know so much about it. Today, we're going to journey with the panel as they share their insights on the replacement of architectural terracotta. So it's my pleasure to hand you over to our panel for today's webinar, who will each introduce themselves, beginning with our very own Joan Berkowitz. Joan.
Thank you, Stephen. Hi, my name is Joan Berkowitz. I'm a technical director here at CANI. I've been in practice for 35 years as an architectural conservator in the New York metropolitan area. Started my career after graduate school at Columbia, worked with the National Park Service. Then for more than a decade, I founded and co-ran an architectural conservation firm in New York. For the last decade, I've done something a little different. I've worked in-house for architectural firms. I'm just approaching my first anniversary here at CANI, where I've really enjoyed providing technical services, conservation, preservation across projects within this office, and really enjoy working together with my preservation colleagues and my 5 conservator colleagues. I'll pass it off to Exusha.
Hi, I'm Exusha Flandreau. I'm also an architectural conservator here at CANI. I too graduated from the Historic Preservation program at Columbia, and then subsequently worked at with the New York City Parks Department, followed by 8 years at a conservation firm here in New York, and at which point I came to CANI. And like Joan, I've been taking a little different role here at CANI, where I work in-house with my fellow project managers and helping them to solve their architectural problems. I'll turn it to Alafia.
Hello, everyone. My name is Alafia Akhtar. I am also a project manager here at CANI and an architectural conservator as well. Similar to Joan and Exusha, I too graduated from Columbia's Historic Preservation program with a concentration in conservation. I worked at an architectural conservation firm for about 2.5 years prior to moving to CANI, where I do work in the restoration side, using my conservation and preservation expertise in a lot of the projects that we do here.
Thank you. So we'll jump right in here. So I know this webinar is about substitute materials, but it's important that we briefly introduce you all to architectural terracotta, so we know what we're substituting. So I'm going to start here. This is actually the official definition of architectural terracotta provided by the National Bureau of Standards, which was kind of taken over by ASTM later. But it's a long definition, but basically what it says is that architectural terracotta is something that is fired, it's ceramic, and it's larger than a brick. Before we get into the technical aspects, I wanted to go through a little bit of history of architectural terracotta in the United States. It actually has been used in the US since the 1840s. It was supposedly dreamt up by an architect named Edbridge Boyden, and he stated that he literally dreamt of the process of using pottery on buildings in place of stone. However, they had been using architectural terracotta in Europe for several decades prior to his dream, so we can kind of take that for what it's worth. Production in the US really ramped up in the 1870s when a man named James Taylor immigrated to the United States from the UK. He had worked at a terracotta plant in the UK and subsequently opened a plant here in the United States. So what is it? It's actually a clay body. Well, we start with a clay body, and that consists of 3 parts: clay, fusible materials, and grog. So the clay portion is actually what's mined directly from the earth. The fusible materials are Fritz and feldspars, and those are items that we add in to lower the melting temperature. And then there is grog, and that's usually unglazed terracotta or brick that has been fired and then crushed into a powder and added back into our mix. And that actually helps us control shrinkage. The next step is that water is added and we mix all these things together. Then it's put through a pug mill, which is the machine here shown on the right. And what that does is it compresses the clay mix into a firm, stiff mix and removes a lot of the air pockets, and it's ready for use. So the next step is really where the magic of architectural terracotta starts. And for our purposes, that means the clay is either molded, cast, modeled, or extruded. And the clay is sort of pressed into this plaster mold, and it's left there to dry. And the plaster absorbs some of the moisture from that clay body. For more intricate elements, they're actually carved on a plaster column and then also left to dry, or a little bit to dry. They're slowly dried out, as we can see this gentleman carving this on the right. The drying process is also very controlled. This can take a few weeks. And the goal for the manufacturers here is to remove enough water to make the piece handleable without deforming it. You don't want too much water out or it'll start cracking, but that leads us to our next step, which is glazing. Once we can handle the unit gently, because they are quite brittle at this point, we can go on to glazing. Glazes actually consist of fine clay particles, chemical colorants, and metallic oxides, and they're mixed together, and they can either be sprayed, dipped, or painted onto the terracotta unit. And as you can see here, what's being spray applied is not the color that you end up with outside of the kiln firing. So this is why when you're replicating units, the color matching process can take so long, because you don't know what your color is going to look like until after it has been fired. So these could very well come out being, dark blue or yellow, even though they're going on as white. Finally, our last step in the manufacturing process is the firing. So everything is put into a large kiln. And the first step is maybe one of the most important, and it's called a soak. And that is where the kiln temperature is raised just below the boiling temperature of water. And that's done to remove excess water in the clay body. You don't want to just put them in there and ramp up the temperature very quickly, because that water will turn to steam and blow your terracotta into thousands of pieces, which obviously no one wants, especially when you're on a schedule. So once the soak is over, and again, the soak can take a few hours to a few days, the temperature is ramped up again and the firing begins. That's about 9,000 degrees Celsius. This is where the chemically bound water is removed and the clay particles begin to fuse together. And then one more ramp up to 1,000 degrees Celsius. This is our final firing. And all those things start to fuse together into glass-like particles, which is called vitrification. So our vitrification happens in this stage. Finally, the cooling has to happen where the kilns are turned off. But again, the temperature has to be lowered slowly, because if you lower it too fast, they go through thermal shock and can crack. Now, one thing to note here is that terracotta has shrinkage. So obviously you saw we put in all that water in our clay body and then we took it all out in the kiln. And when we take all that out, we end up with a significant amount of shrinkage. For terracotta, architectural terracotta manufacturers, the goal is to get their shrinkage between 3 and 8%. And so they maintain that. What that means though is when you're trying to replicate a specific unit, the manufacturer has to model a unit that is 3 to 8% larger than the one you are giving them as a match. So finally, after inspection, everything is shipped off and ready for our use. Briefly, how terracotta fails. So typically, historic terracotta is hung with still anchorage, meaning it has straps, rods, hooks that are usually ferrous in nature. And when water starts to get into that system, either through open mortar joints or other failures like small cracks, it starts to corrode those ferrous embedments. And then rust jacking occurs, which means that it starts to sort of push things apart. That allows for more water to get in. And in New York City, that results in freeze-thaw damage, especially in the spring. So the problems begin to get exponentially worse until eventually you end up with a catastrophic failure where a piece could fall from a building, which is actually how here in New York, we ended up with the local law 11, now known as FISP inspections, is because a piece of terracotta fell from a building in 1979 and killed a student up at Barnard. So inspecting terracotta is obviously very important because not only do you want to take care of your building, but you also want to maintain the safety of those who are walking around your building. So now I'll turn the time over to Joan.
Thanks, Exusha. So just before we slide into the actual discussion of the available substitute materials, I wanted to just remind everybody that there are some factors at play here, particularly in New York and I assume elsewhere. And that, as Exusha mentioned, the architectural terracotta is, much of it is over 100 years old. We've had some crazy failures in New York, despite our facade regulations. Replacing terracotta in New York City has become more common. The New York City Department of Buildings has listed failing terracotta as one of the 3 major facade failure issues facing buildings in New York. So if we can't repair an underlying condition, we come back, we used to pin, we used to patch, et cetera, et cetera. Now we actually have to replace those units. So if we can't replace them in kind, which is my first choice, I would pick terracotta each time. Then we have to have a bunch of considerations and several substitute materials that we can select from. There are other considerations on top of that when you get to substitute materials, lead times, cost, color. Will the material properties allow us to do our work? What are the building's characteristics like as a whole? Are these going to be very visible, or are they going to be down at the street level? And of course, in New York, we have a pretty strict landmarks law, which has actually gotten even stricter regarding the installation of substitute materials. In fact, in New York City, very, very difficult to use a substitute material for terracotta on an individually designated landmark. So substitute materials aren't a new concept. Terracotta itself is, in fact, a substitute material for stone. Cast iron is a substitute material for stone. These are mechanized, mass-produced materials that were available. So we do have this broad selection. We can choose from cast stone, architectural precast, GFRC. There are 2 proprietary systems we're going to introduce, and then fiberglass, or FRP. I think it's really important to note that all of these materials are cast, and each of the steps that were involved in replicating terracotta are actually involved in using these materials. We need molds, sculptures, etc., documentation, scanning. Units need to be removed, sent to fabricators. But it is really important to note none of these are terracotta. And frankly, none of these substitute materials are fired. They are all set chemically, and none of these materials are glazed whatsoever. They may be coated to simulate glaze and colored, and they do require color matching, but they are not actually glazed. As far as the properties for terracotta, replacement materials, each of these has pros and cons. And we try to look for, what we call compatibility and strength. It's interesting that many of the available substitute materials have similar compressive strengths, similar water absorption, and really very good freeze-thaw durability. So onward to individual examples of the materials. Cast stone is a very common material. There are 2 kinds usually. We often use the wet cast rather than the dry tamp. In New York, it's very common. We actually have less space, and the dry tamp gets many, many more units out of a mold in a shorter period of time. So I have had that explained to me as the reason. Cast stone is architectural concrete, and it has been used to simulate natural stone. We do use it to simulate terracotta. It is heavy. It is made of a mix of aggregates, colors, pigments, cements. It is heavy, which will affect its installation. And interestingly, cast stone actually sits within Division 4 of the CSI, and they have their own Cast Stone Institute. So it sits in masonry. Now I'm going to hand this to Alafia. She's going to show us a case study.
Hello, everyone. I'm going to run through an example where cast stone was substituted for terracotta in a recent Canny project. A facade investigation to determine the repair scope of this terracotta building on the left, located in Midtown Manhattan, that was constructed between about 1912 and 1914, revealed that the ornate terracotta flagpole base was severely deteriorated. The existing units, as seen in these up-close photographs, exhibited glaze loss and open mortar joints between units. They were also previously patched, pinned, and stapled, all of which had come to the end of their serviceable life. The backup masonry was also observed to be cracked and underlying steel support system severely corroded, causing further deterioration of the terracotta units. Per New York City's DOB rules, as Joan previously went over, any terracotta unit previously repaired cannot be re-repaired, but instead must be replaced. Therefore, the flagpole base was to be replaced in kind per the original repair scope of work. However, due to the prolonged terracotta production timeline, coupled with tight project schedule, ownership opted for cast stone as replacement material for the entire flagpole base. The supporting steel was first replaced and the backup masonry rebuilt and appropriately waterproofed prior to the installation of replacement cast stone units at the flagpole base. The cast stone was replicated to match the existing terracotta in size, thickness, and shape. The reproduction of the cast stone took approximately 3.5 months from the time of the approved shop drawings. The glaze of the original terracotta units varied from unit to unit. In order to replicate this effect, Canny worked with the cast stone fabricator to shop produce multiple color variations for the replacement units, so that the cast stone matched the existing historic terracotta as closely as possible. This is exhibited at the top left photo. The right two photographs illustrate the rebuilding process. First, the dry fitting of the units to ensure their secure fit within the space and against the backup, and then the commencement of the final installation. This is a quick side-by-side comparison of the original terracotta base on the left and the replacement cast stone base on the right, and their close match, as you can see. Here's one final photograph of the complete base. Unfortunately, due to the access of the base, an overview photograph was unable to be obtained without scaffold, but you can see how closely cast stone replicated what the original terracotta looks like.
Thank you. Next, architectural precast. Precast is what we use really most commonly. It is not entirely different at all from cast stone. It is any product truly that is cast off-site and not poured in place. Again, it is a mixture of cements, aggregates, and colors with surface finishing taken from cast stone, exposing aggregate, other different things like that. It's interesting to note that although the materials are almost the same, or the product, that precast manufacturers identify with concrete, and their product actually sits in Division 3 of CSI, and they have their own institute called the Precast Pre-Stressed Concrete Institute. The good news here is, as Alafia mentioned, this is a material that can be molded and brought to the job site within a few months of approval of color samples. Here are just two examples of architectural precast in place. A building in Soho on the right, very moldable windowsills, window surrounds, an entrance of a building in Brooklyn on the left. Very nice aesthetic results, good properties, and a material that we use on a very regular basis. GFRC is another material that we use often. It's a little different and a little the same. Again, it's cementitious, it's composite. What makes it different is there are glass fibers that are alkali resistant, suspended in the matrix. It makes the material stronger. We can use it in a thinner way, with a hollow back. The material might be hung on site, can be actually panelized, which is interesting. So that might be more expensive as a fabrication, and yet the installation may be less expensive. So we do use GFRC. It's fairly common for us. Let's see. Again, and we can generally have that on site in that same time frame of 3 months, 12 weeks from approval. Color matching, you can see right here on the left is a color matching library. One of the fabricators we work often with, they save all of their recipes to help them. This lightweight material you can see on the right, and the griffins that were reproduced came back in 2 units. They are hollow, and that hollowing out of the unit has given them great lightness. They are also installed very high to a good visual effect. So I think the level at which we're viewing these materials affects our selection or our choice. In fact, the Landmarks Commission allows for installation of substitute materials above the 6th floor in certain situations. So I'm going to give that back to Alafia.
So I'm going to go through another case study where GFRC was installed in place of Terra Cotta. During a routine facade inspection and safety program investigation, the Terra Cotta facade of this building shown on the left, located in Gramercy, New York, constructed around 1910, was inspected. The existing Terra Cotta exhibited varying levels of deterioration. However, the most severe conditions were observed at the spandrel panels. These units were cracked and spalled and consisted of multiple previous repairs, such as large-scale patching, pinning, and crack repair, all exhibiting signs of deterioration. The original repair scope for this project consisted of replacement of terra cotta in kind. However, due to the prolonged terra cotta production timeline, ownership opted for a GFRC alternative. Canny designed GFRC units to be installed at the spandrel locations as independent systems within the field of terra cotta. These units were installed at the building from floors 3 to 12. Existing steel assemblies were restored and painted. Cementitious parging was applied to the backup before the waterproofing application. New supporting steel clips were attached to the existing steel assemblies and backup masonry as seen at the top left photograph. The GFRC units themselves were prefabricated to replicate the existing terra cotta units in color, size, and texture. Mold for these units is shown on the top right photograph. Steel frames were attached to the back of the units by means of gravity pins embedded within the units. These frames were mechanically attached to the new supporting steel assemblies, corresponding to the steel clips at the spandrel locations at each floor shown in the bottom left photograph. The GFRC units were isolated from the terra cotta with a sealant joint. At the left here is a close-up photograph of the completed GFRC panel system at a spandrel location, and at the right is an overview of the completed installation at all floors. As you can see, the colors are relatively close to the terra cotta.
Thanks, Alafia. We're actually going to introduce 2 proprietary systems quickly because we believe they're viable options. The first one is a cast cementitious material. It's called Terra Cotta. It's not actually a new material. It has been in use. It's in Edison's formulation for terracotta repair, but used as a casting material. So it's been used easily for 15, 20 years. Again, it has a lot of the properties that we would like to see in a replication material. We're looking for some mechanical compatibility. This is actually molded. And again, the molds are hollowed out. So this material can be quite lightweight, get a nice texture match, and can also coat to simulate glaze. So here's an example that the manufacturer sent to me, show the damaged unit on the top, the molding process, a unit that was pulled out of a mold, and the unit on the right, which has been coated with an Edison coating. And I think it's actually fairly compelling, and that's why we included it in this presentation. Again, this probably has a pretty quick lead time. probably, I think, 8 weeks once color samples are approved. Another example of the same product, actually, it can be used as cast in place to replace terracotta. This is on a building in Manhattan. This is not our project. This was supplied by the manufacturer. But again, they are building an armature. They have a mold. They're casting it in place, and then they have coated it. And again, I think that's a fairly compelling replication piece. Second one we're going to just introduce briefly is a resin-based material, commonly known as microcotta. It is a polymer composite that combines with aggregates. It's very castable. It has been around for, they will tell you, almost 40 years. Nice color retention, good possibilities, very nice molding. It's very light. And here is an example of aged and deteriorated terracotta piece on the left, on the right from the literature, their color match and their texture match. Another example of the microcotta building on the Upper West Side of New York. They actually replaced the Juliet balconies with microcotta. Again, it is very lightweight material and seen at great height was quite useful. And I think that actually looked pretty good. Last but not least, we have fiberglass or FRP. I do believe that there's a place in terracotta replacement with fiberglass. I think particularly for cornices, it can be very, very effective, and for units at height. Again, large sections can be fabricated. They're lightweight. You can accomplish great detail as seen in the mold and on the element to the right. They are much more UV stable than they used to be. So the color retention is much better. And the turnaround time for installation is fairly quick on this as well. There you go. Another intricate mold, another pretty cornice. Very light, hung up there on a system. Again, another one, really pretty though, and you can see the armature that it's been constructed on the right. So there is some work that goes into the installation, but these can come in large panels, and you can see the sort of dramatic effect that this has as a cornice. Again, a perfectly reasonable option at times. So this is actually going to bring us to the end of a portion of our discussion. I think it's important for us to note that we're not advocating for any of these in particular. We're educating. We're actually saying there are options out there. I think I read the statistic that terracotta was used in New York on every third building or something at a particular time during New York's construction. There's no way that we can use real architectural terracotta on all of those projects. And I don't know that it's necessary. I'm a preservationist, and on landmarks and on buildings of historical significance and buildings in historic district, I will go to the mat for replacement in kind in terracotta. However, we have to be responsive to our clients, and there are other kinds of buildings. There are other buildings that have different historic significance, different detailing, and some of those clients, owners, they can't wait 12 months to get real architectural terracotta from Boston Valley or Gladding McVean, or even the 5 months that Darwin is quoting now. So although there are 3 really good options, it's not always a possibility. Made this little chart, partially borrowed, partially doctored, just to talk about the 3 materials that we use very commonly. As a review, it's easy to see that the GFRC is much lighter, although it uses molds. Things can come in panels. The design of each material has some pros and cons to help us. The production methods, again, very similar, interesting, similar timeframes. This concept of structural versus non-structural has to do with attachment on buildings has to do with the weight of the product. Cast stone is very heavy, and it's really not something that we might drop right adjacent to or on top of a piece of terracotta. So these are some of the considerations that we pass off to, or I pass them off to my architect colleagues and my structural engineer colleagues. Alafia, Exusha, thoughts on what we're talking about today and substitute materials?
Well, I think I agree with you that there's a place for all of these. I will also go to the mat for reusing terracotta in kind when it's appropriate, but there's also some times where these substitute materials might perform better than the original terracotta because of maybe, waterproofing, detailing, or other things happening on the building.
Agreed, definitely. Just seeing an application too, and the where we end up using the substitute materials, sometimes they just work better. In kind of marrying the historic versus the new as well.
I have a question from somebody. They're asking for the microcotta and FRP. Aren't there fire rating issues?
Yes. So I think, as I understand that says that, I believe on my microcotta slide, at the moment, I'm not sure that they are compliant with the NFP fire spread regulation. Evidently, the gel coat does have some flame to it. As in my conversations with microcotta, they say they have dealt with the flame resistance issues. So I think we're going to drill down a little more into that. I personally have never used microcotta, although I am open to it. I'm not sure that having a gel coat flame on an isolated unit is a huge issue. We'll get back to you on that. I think we're going to do a little further investigation on that one.
No further questions at this time. If anybody else has questions, please submit them through the chat or the Q&A.
I mean, for me, the topic is very interesting and it's evolving, which is even more interesting. I've been working for a long time and I am a purist, and I do think that replacement in kind is preferred, but it is really nice to know now that there are some options that we can pull out of our hat or our deck and try to use on buildings. There are different situations, there are different deterioration patterns. There are clients, again, with different financial constraints and timing constraints. Just to know that there's a material that we can use, that we can get installed in 3 or 4 months is terrific. I don't know, I somehow find it reassuring. I think that, I'm actually pleased that the landmarks law has gotten stricter as far as substitute materials. I think that it was fair to raise that standard. I think that we were losing a lot of terracotta in New York on landmarks. In fact, here at Canny, we're working on a project now down on Madison Avenue that's an individual landmark. And evidently a decade ago, we used some cast stone on the building. And now, because the landmarks change, we're actually coming back with absolutely stunning terracotta. So that's pretty exciting.
I've got 4 questions coming in. I'm going to just put them in front of you, Joan, and if you could start working through those.
Okay, let's see what we have.
Reading them out.
They're over there?
No,
Middle.
top.
Okay. Okay, lead times for the 3 major terracotta manufacturers from Color and Shops.
So for the manufacturer out of the UK, I spoke with them yesterday. And after your shop drawings are done and your color matching is approved, their lead time is 16 weeks.
Which is remarkable.
Right. For the other 2 manufacturers here in the US, I believe their lead time right now is slightly longer, although I don't have an exact week.
It's about, from some of the last projects, it's about 12 to 18 months from what we're hearing within the office as well.
Got it. Okay. Another question. Compatibility between existing historic terracotta and the substitute Portland products. We do not generally insert concrete bricks into a clay brick facade. No, we don't. It's interesting. I think great care is taken here when new materials are introduced adjacent to existing historic materials to support them independently and separately, to isolate them from one another.
Yeah, I think, so we recently worked on a project where we replaced, you know, individual units of terracotta with precast. And what we did was we isolated them not only because they're supported by their own still structure, but also using neoprene pads, as well as a very specific mortar, which would kind of take up compression if it ran into that situation where maybe there's, you know, a freeze thaw cycle or something that puts it under a little stress. We have a lot of belts and suspenders to help us not damage that adjacent terracotta.
Which is terrific.
Mhm.
And a funny thing is, just this morning, Exucia sent me over some compressive strength data from 1918 on historic terracotta, and it's all over the map, from 2200 psi to 17,000.
Yeah.
Which is really pretty remarkable. And I don't know, I think building materials, yes, and the notion of compatibility is very important. We certainly don't want to install anything that will bear on terracotta and damage it, or anything that would, you know, damage it in any other way.
So you have more questions down here and one over here as well.
Okay, here we go. How do we define that a terracotta unit can be repaired or replaced?
There's all sorts of ways, but in New York, if it has been repaired before, you have to replace it. They will not let you repair a unit twice.
Or re-repair an existing
Right.
repair.
So you have to address the underlying condition. So that's one key right off the bat. The other is that, say like you do run into a situation where maybe you can do some pins or patching where, you know, per the requirements, if we're gonna try pinning a unit, we're gonna pin it and then do pull tests to prove that the pins are working how we need them to. So it's often a time, you're not only doing an inspection, but then you're also doing a testing campaign to back up your findings and your proposed repairs.
Right, and with the pull test too, nowadays with DOB is often requiring the pull test to be filed, especially when you're filing a FISP report, you know, to basically have proof that you did do all of those things before submitting.
Okay.
Thank you. Another one, do we think the landmarks will ever approve the substitute material between the magic 6-story level? The answer is, I think yes, and I think they do. I think that firms that are nuanced and experienced with landmarks have greater success. If you read the new rules, there are substitutes approved below the 6th floor in special situations. I think it's a matter of if those special situations exist, i.e. replacing with real architectural terracotta will somehow damage or cause you to lose more architectural terracotta. That's a possibility, and might also be able to quote, it looks like precedent from previous approvals under the previous law. So always a possibility. Somebody will go to court with that someday and challenge it because it is a pretty stringent regulation. But until then, we just navigate that through dialogue with landmarks as best we can. All right, let's see now. Question: is there an option of terracotta unit that are loose and shifted that we can pin? I mean, the answer is yes. We used to do a lot of pinning in terracotta.
If it hasn't been pinned before. as a
Right,
caveat.
in New York, if it hasn't been pinned before. Repinning of terracotta or things that have moved after they have been pinned is no longer accepted by our Department of Buildings. So yes, I would say that there are a variety of pins on the market, and there are some that are particularly geared for terracotta and use in hollow cells. And I think if you can be sure that you're not pinning into air and that you're actually pinning into backup, and you can do some pull testing to show that you're getting good adhesion, that pinning can be a viable option. It's just a less viable option for us than it used to be here.
Question, can you discuss your recent experiences with the New York City LPC and their willingness to use alternate materials? I think you, which materials would you lean towards instead of using terracotta?
It really depends on the situation.
Yeah.
Because, you know, they're like the example Lafayette showed, that lends itself very nicely for GFRC to go in as a panel.
Yeah.
But you know, if you're doing just a single unit of replacement, precast or something of that nature, even, you know, one of the proprietary systems might be more viable for your project. So it really is a case by case scenario.
Right.
Can you address the differences in thermal coefficient of expansion between terracotta and the substitute materials and how that would influence detailing?
Yes, so they do have different coefficients of expansion and contraction, and basically what you do is you create space. You put space between your terracotta and your replacement substitute material, and you isolate them, whether that be with waterproofing membranes, you know, backer rods, joining pads, silicone joints. There's just a variety of ways to give them the space they need to not compress and break your original terracotta.
Yeah, sealant joints aren't always a viable option, depending on if you're doing within a field of terracotta. I mean, then oftentimes, as Exusha mentioned before, it might be good to look into different types of mortars and their softness to kind of consider when considering the movements.
And
of
even
materials.
sometimes manufacturing your replacement slightly smaller than it was originally to make your joint bigger, to give that space.
And at 10 stories, 5 stories, 4 stories, you wouldn't notice that space. So it really is an option.
Quick question, what's the reason for the long lead times? Is it just the color match?
No, it's the whole process. Yeah, the whole thing from beginning to end is, you know, every step of the way I showed where, you know, you're molding, you're drying, each one of those can take weeks. So.
And then there's the demand.
Right.
Each of these terracotta manufacturers does not only work on replication or making, you know, new terracotta for us on our historic buildings. If you look at their websites, they make terracotta for rain screens. They make terracotta for some of the most beautiful new architecture that's being built right now. And they are busy. I mean, I think if I had any money and an inclination to start a fabrication process, I think that's the direction I'd go. I think as a cladding material, terracotta is absolutely having, you know, yet another renaissance in color and shape and form, because it's just so malleable in that way.
Well, I think also because of LPC's rules, I mean, more and more people are having to use terracotta at below the 6th floor. But then also, you know, you have decorative terracotta, and the decorative terracotta definitely takes a lot more time than if you were producing ashlar units that could be extruded.
And all three of the manufacturers will start the replication process and the color matching at the same time. So you don't have to wait for your unit to come out of the kiln to start your glaze matching. They'll start them, they'll run them simultaneously.
Right.
So perhaps related to your question or your idea, do you have any experience with alternate terracotta manufacturers in the US or abroad?
Darwin.
Yeah, so I've worked with Darwin before.
Yep.
Superior Clay out of Ohio, somebody's asking.
Yeah, they do a lot of things that are unglazed. They do a little bit of glazed, but I think my experience with them is they've been more for like chimneys, things like that, but they are turning towards architectural terracotta because they can.
Okay.
And yeah, I had an experience with them probably 20 years ago. Not a great experience, but then they stopped doing architectural terracotta for a while. I gather they're back, and they were good people and they really understood the materials. So I would imagine that they would, you know, would give them a chance to make a good product.
Some questions around anchorage. A question is stainless steel always used for replacement anchorage?
Preferable.
Yes.
Stainless steel is always preferable. I don't necessarily think it's always used, but that is definitely, I mean, person in Canny, we always specify stainless steel as the number one.
And somebody's interested in us exploring this whole area of Anchorage at some later point.
Wonderful.
Yeah.
You know, it's weird because when terracotta was invented and used, people thought this is incredibly durable material. It's moisture resistant. It's this and this. I don't think they realized that water was going to get in all those joints and corrode all that steel. And so, in fact, it is not the terracotta itself that is failing. It is sort of being forced to fail often by its anchorages. So yeah, I think stainless steel is the way to go. It'd be too bad to repeat that mistake.
I mean, I always like to put in the plug for terracotta that it's failing at 100+ years. What material are you going to get to last 100 years besides terracotta?
And maybe granite. That's right.
Yeah.
A question here that's interesting. What are the site logistics from identifying replacement units on a building and executing replacement related to scaffolding and hands-on inspection? Alafia?
I mean, it's definitely, it takes a lot, we've had projects where we've done the entire investigation before, especially where you're doing replacement with terracotta, so that you can kind of get the process started right away. And then kind of come back as everything is being produced and start doing the other work. So it is ideal to kind of take that into account when you are looking at a project to make sure that, if it be terracotta or any other replacement material, that, you get your hands on all parts of the building right away. So identify these materials to basically cut through the lead time that these materials could potentially have.
And I had a discussion actually with one of the manufacturers here in the US, and I said, what can we do to speed this up?
Yeah.
Because it's the lead times that are killing it. And they said, well, if you can get an owner to contract simultaneously with us as you are doing your inspections, your initial inspections, we can start the process. So they can start doing their shop drawings and their molds and all that before construction documents are even written. And that just helps get that ball rolling. So you're in the queue before another project starts up.
And I'm not sure to what extent, but these producers are actually pretty savvy, and they're now using laser scanning.
Yep.
They're using computer printing of units for mold making and other things. And some of that actually would tend to speed up the process.
And somewhat related is the requirement to only repair a damaged unit one at a time, unique to the New York City condition. Is it driven by the thermal conditions in northern climates, or is that a best practice whenever a terracotta repair is undertaken?
I like to say that it's a best practice, but in New York, it is driven by people being killed by terracotta that was previously repaired.
Yeah.
But it is a best practice that if you have a unit that was damaged before and you see the damage happening again, you should address the underlying conditions.
Right, because there's only so much meat left in the terracotta to repair if you keep repairing it.
Right.
How has the laser survey assisted in speeding up the process?
I think just as plain old documentation, drawing, measuring, reproducing. I'm not an expert on laser scanning, but I certainly know that some of the fabricators, particularly in the cast stone and in the terracotta, have been using it. I think a laser could scan, a zillion more points than we could measure, with a tape measure or get on a photograph. So,
yeah.
Back to the substitute materials, do you see any adhesion problems with mortar or sealants when using them?
Yes. So
yes.
The resin-based materials, you have to use a primer before you point with a standard mortar, because a standard mortar without that primer, either in the mortar or on that substitute material, will not stick.
And truthfully, your fabricators should warn you, and you should ask them, do I need a primer? Do I need to acid, wash this? A lot of the precast and cast stone does get a light acid wash before it comes to the building or before it gets coated. So things have better adhesion, just to take the sort of cream off of the new units, off of the units.
And I think this is more of a comment than a question. I believe that this individual actually works for Darwin themselves. He's simply saying demand has certainly exceeded supply for architectural terracotta over the past few years, but as manufacturers, we're working hard to reduce lead times by improving our processes and increasing our capacity. We hope you will give us the opportunity to provide a product as a first result. Thank you for that. We're going to wrap up shortly, but I'm just going to take a couple more questions. Do you see 3D printing as a viable solution? Would any of these materials lend itself to it?
Yes, so 3D printing actually already plays a role in this process, because you can scan something, put it into something like Revit or CAD, and 3D print your model.
Yep.
So that right there cuts off, 2 or 3 weeks worth of production time that we don't need anymore. As far as 3D printing the actual unit, I don't know that we're there yet. I think the materials used in 3D printing are a little too transient right now to use it on a building.
Great. Final question. What is the future of terracotta? Will we see a comeback in production capacity in traditional terracotta? I think we sort of just spoke a little bit about that, or will we continue to see a shift to substitute materials?
I mean, I think terracotta is here to stay. I think that it's not going anywhere. I think that the fact that Darwin is, in business and booming, as is Gladys McBean and Boston Valley, and that Superior Clay is coming back, that in fact, there's a tremendous demand for terracotta.
Yeah.
And again, we would replace in kind, and we do choose to when we can and when we think it's appropriate, particularly on landmarks. And yeah, I think terracotta has a great future, particularly looking at the way it's being used. Oh, this amazing new construction.
Yeah, I think
For any energy reasons,
Yep.
terracotta is quite nice environmentally. Yes, we use a lot when we're firing those materials, but we can reuse what didn't work out, so I'm not calling it a green material, but it can be a little better than something, some of the other substitutes out there.
And I think, like Exusha said earlier, I mean, it is a material that's known to last 100+ years, that's a big deal, especially nowadays with new construction going and the alternative materials that we do have that don't necessarily last as long. So, yeah.
Thank you. Firstly, I want to just say thank you to all the attendees for joining us today. Some really great questions coming through. There will be a copy of this presentation made available afterwards. And we'll certainly entertain further questions and inquiries. You can reach us at info@kenny.com. I finally want to thank our panelists, Alafia, Exusha, and Joan, for a very entertaining presentation and navigating through all the questions. So thank you very much, and enjoy your afternoon. Thank you.
Thank you.
Thank you.
Good stuff. Really good.